So I do have like 37 slides for whatever, 45, 50 minutes, so it will be a marathon. And there is a, like, it's not my vision, my duty. You study, your study habits are personal things. You arrange them as you wish. But once in my freshman times, I was very late in things, stopped understanding anything. And the way that I got a suggestion from someone else to each evening after a lecture read read my own notes and maybe even write something after each line, like wrong, I do not understand, or like maybe some more valuable comments. Starting next week, we'll go in a more regular traditional style with maybe a little homeworks and some tools to memorize things, and we will do some presentations. And right now it is substantial, relatively long interval when you are just listening, but it doesn't mean that this information is useless. So I have some hopes that something will be taken by you as a take-home message, because we will build on that. It's a little bit vague and philosophical, and I'm not going to question how well you remember those stuff, but it will be used later as foundation. Let's go. So, if you are busy and want to live, on one hand, and if each of these equations doesn't surprise you and are well familiar for you, then you stand up. They're not too complicated, and it will be not a surprise for me if you are aware of them. Like, I have hopes that first equation is familiar to most of you. And I have high expectations that Alice and Morgan are aware of the last equation. Maybe the rest of you as well. Okay? So, I was asking what's the name of the equation, but it's already written. So the goal that we will not reach today, we will reach it early on Monday. But our goal is to derive this equation, to set up logic behind Schrödinger equation. And a lot of physical chemistry and quantum theory courses start from this equation. But we are trying to build up a little logic behind it, so where it comes from. So this is the wave equation for electron. Unlike wave equation for waves on the surface of a lake, there is first derivative of time over time. Not second, but first. There is an imaginary unit that we will refresh today, and all other differential operators are hidden in the energy operator. And everything we do will serve like a trampoline to feel happy about this equation. The first one, you either know it from heart or you will refresh it today. This one is summary of our philosophical ideas from our previous meetings. Right? So electron is moving, accumulates action, letter S, and this action comes as a phase in as an argument of trigonometric function, sine of a sine, or more generally into oscillating exponential. And this one is a replacement of Schrödinger equation, which is mathematically more complicated, but philosophically it should come earlier than Schrödinger equation. It's basically a way to predict future, how to go from initial time to a function to final. Okay? So it's a summary. I need to get all of your emails and send you maybe slides and links. So this stuff are recordings from previous years, and these two are from our previous meetings. Watch and maybe see your faces there. Stuff. Yeah. Not that unavailable. Too bad. I would probably include the link to YouTube or whatever. But this is online. Put this on Wikipedia, modeling of the wave current from double speed, and it shows dynamics of formation of fringes and moving all those. And this is the stuff that we did last time, right? So action of angular momentum is energy. And we talked about here that electrons are moving along the trajectory and accumulate action, and we have big hope that this action can be used as an argument of trigonometric function. Having a vague discussion about Bohr atom, but our goal is Schrödinger equation. Is something more general that can be applicable not only to this oversimplified one-dimensional rotations, but to anything that has features. And this is just repetition of what, our main observation. If we divide action by Planck constant, or if we multiply position times momentum, angular momentum divided by Planck constant, in Bohr's model, it should be integer number. Same dimension, and the integer number means portions, quantized, therefore the name of quantum theory. So please stop me if I'm running too quick, but running, speaking. So we offer a hypothesis that action corresponding to a path divided by Planck constant will be an angle that can serve as an argument, an angle that enters into the trigonometric function. And our waves are like sines, cosines, or maybe something more complicated. So this is hypothesis that later we will generalize it. We will never use it practically, but it is just a summary of an idea that the wave of electrons is like sine of a sine, where argument of the sine of a sine is action corresponding to the path it has traveled to a certain point. And the sine and cosine functions are not sufficiently good. There's something wrong with them that make them insufficient for quantum theory. If you look back into history of civilization, originally there were only integer numbers, like number of apples or number of bricks. And then people start sharing and cutting halves, fractional, rational numbers. And then as soon as more operations appeared, it turned that rational numbers are not sufficient to some operations. Which operation brings us away from rational numbers? It's all written there, if you can read. So if you solve the quadratic equation, right? Some solutions are coming like this values square root of negative numbers, and they are not rational. So it gives another dimension for like basic math. So it's not my frivolous wish to torture young minds. It's just an objective part of physical chemistry and quantum theory. We cannot survive without it. So
there is a generalization for rational numbers which is called complex numbers. So it is a term. It is not because, oh, they're so complex. It is complex because they are composed of two rational numbers. And typically one composes them as one rational number multiplied by 1, and another rational number multiplied by 1 in this imaginary space, square root of -1. Right? The square root of -1 denoted as letter I is just an abstraction that follows the following property. Square of I equals -1. Okay? So these numbers are needed to enrich our way to model systems. So if there are two real numbers, like component along regular dimension, real, and component along another imaginary direction, one can record it, one can imagine it as planar two-dimensional geometry, right? So point specified by two projections, x and y. And one in the real dimension can be recorded as regular one, and one in the imaginary direction can be recorded as I. And those projections are called real and imaginary. Imaginary because it is something that we do not touch, not from our real world. Real and imaginary, x and y. And then most things that we studied in middle or high school about planar geometry apply here, like trigonometry. If you have a length of the complex number, then we can set up an angle and use like trigonometric functions with definitions of sines and cosines, right? Pythagorean theorem, right? Things like that. So this x projection will be length times cosine, y will be length times sine, right? And if you divide x over r and take inverse cosine, it will be angle. So the length, which is also denoted as absolute value with two vertical lines, is just like Pythagorean theorem. Square root of squares of x and y projections. And then if we summarize this stuff, so x projection is length times cosine, y projection is length times sine. And overall, the complex number is a vector, two-dimensional vector, where the basis functions are 1 and I. Right? So real, imaginary. Real, imaginary part. So it is a summation of real and imaginary part. And if we practice polar coordinates, then it is stored as summation of this. Real times 1, imaginary times I. Are you surprised or insulted by the word polar? Polar bear, polar cold, polar coordinates. Probably it's coordinates on the North Pole, right? Polar because there is a pole. Origin is pole and everything revolves around it. And instead of specifying point on a plane by two Cartesian projections by 90 degrees, one can instead use distance and angle. Or coordinates. So, how does Euler helps us? Where he comes into this activity? I see in your eyes that you remember something vaguely, but you need maybe a little more certainty. So, Euler was a blind mathematician. So it was okay for him to browse in the imaginary space. And his equation is a way to shorten these recordings. Like if I'm writing a COS phi, I'm already tired. But if we are intentionally thinking about complex plane, we know that there will be two projections, and we know that if length equals 1, this will be a equation of circle, right? X and y will form a circle. So there is a convention offered by Euler to replace this notation by exponential to power I phi. So it's like definition. If you see e to the imaginary power, you should forget about it and immediately imagine this notation. So it is two-dimensional complex thing with real and imaginary components which are sine and cosine of the same. Okay? Stop me, ask questions. Do not let me to go too far without keeping contact. So this was one cornerstone of today's meeting, and another one will be the so-called evolution operator. When we started, and there were 4 equations, Euler was number 1. The philosophical think about accumulation phase in form of action was number 2. Number 4 was Schrödinger equation. We do not have time to get to. And number 3 was evolution operator, a way to predict future. So we are going to summarize our discussions and philosophical concepts and these little ideas of math background into way to predict future. So in some sense, it is the goal of science, or at least theoretical part of the science. So describe an experiment without doing it. That has been done in the past or has never been done. So we have enough concepts and equations that connect this concept to predict the future. In the simplest way, what was in the deterministic Newtonian mechanics, one can predict trajectory. But in more advanced way, one can predict this shape of electronic clouds as they change with time under some external perturbation. Same thing, just this other handwriting. So, Euler. Accumulation phase. There is a little thing that maybe we have time, but I do not want to risk, because some of you need to go to other class or have big plans for the weekend. But if you never planned to practice physical chemistry as your main profession, is there any benefit from knowing Euler's equation? I do have a practical help. If by some reason I will need to serve as the high school math teacher, it will be based on Euler, otherwise I will not disclose the equation itself. So all complicated trigonometric equations are consequences of Euler equation. So one can derive them, and I never count on my memory when I need one of these trigonometric equations. I just rederive them, because if connection with internet is slow, there is no cheat sheet. And this is much easier. So it's maybe 10 minutes. We will not do it, but I'll show this. And if you have nothing to do rather than derive equations on the weekend, which I doubt, it's an interesting exercise. But it's not sufficiently important that to make it as a homework, but let me just show generally. So there is the property of exponentials. So the exponential product of two exponentials is exponential summation of their arguments, right? It's not a surprise. But it's on the left hand. On the right hand, exponential of summation, it will be Euler function for this summation of argument. Sine plus I cosine, cosine plus I sine of the summation. But if you look from the third angle, it will be product of cosine alpha, I sine alpha, and same stuff of beta. So it's algebraic product of two components. And if we open these brackets and then establish equality sign between real and imaginary components of left and right, equations like cosine of summation will pop up automatically. And it looks rather reliable. I was lazy to type it in. Handwriting is a little quicker. So, action, goal is to predict the future. And one more mathematical, it's not tricky, it is a background. If there is a concept of so-called conjugation. So for complex number, there is a concept of conjugation, which means flip sign of the imaginary part. Just put minus instead of plus. And on the plane, it means that you just do mirror reflection in respect to real axis. So if it is z without star, then this is z with star. And there is a property that product of complex number to its own conjugate will be 1. Z times z star equals 1. So if we put star, we automatically change the sign of imaginary in front of imaginary unit, right? And then if you don't have star, if you don't have minus here, then it will be like e to the power a, where a is equal I is high, times e minus a, which equals e times a divided by e times a, which will be 1, right? So conjugation is times non-conjugated will be always 1. We are going to practice it at a time when wave function needs to be interpreted. When we will ask ourselves a question, once again, a question: what is oscillating in the Bohr atom or in any quantum system? So, like, if you have waves on the surface of a lake, you know it's like waves of water, deviation from the equilibrium level. But what is oscillating in electrons? And there are interpretations. If you do have, if you're tired, you can close eyes and ears and relax a little bit, because we will return to this again and again. It's just a little heads up. So do not focus. Prepare, there will be something to focus at later. So suppose that we already have wave function, and we have conjugation of a function and multiply them by itself. So wave function itself is a fiction. It doesn't have interpretation. But the wave function times its conjugate does have two philosophical interpretations. And 100 years ago, there were groups of scientists who were arguing and clashing about it. Now, kind of one group win over, but there are still people who have some doubts, but just do not express them in public. So interpretation of the square of wave function times conjugation is twofold. One, commonly accepted, that it is probability to find an electron in the vicinity of this position at this point in time. Probability is something that we can interpret. Another interpretation that is not accepted, but people know about it, is density of electrons, amount of electrons at given position in time. So probability means we have probability that electron will be here and there. And density means that we can take electron as a chewing gum and distribute it in space and have a little bit here, a little bit there. So do not say it in public. This interpretation lost competition. Always in public say square of the wave function is probability to find an electron. So wave and specific position, if the probability is high, then we will find it. If it is low, we will not find it. So this S, P, D orbitals, they are bigger in certain areas of space and smaller in other areas of space. Those are waves of probability. Slowly wake up, not to your full intellectual capacity. So this summary of the philosophical ideas that wave is trigonometric or exponential function or argument comes from the action is not bad. And Prince Louis de Broglie got a Nobel Prize for it, and therefore those are called de Broglie waves. But it is not rigorous sufficiently. In this form, we cannot derive equations, we cannot predict future, we cannot predict outcomes of experiments. It should be somewhat more certain. So this one is definition of action. Integral from initial time to final time of the Lagrangian, which is like kinetic minus potential. So interestingly, if you noticed a little change in notation, the brackets here are square rather than angular. So it means typically when we have functions, it's like dependence of one number on another number or sequence. If you have Excel sheet, column of X, column of Y. Angular bracket means that action as a number depends on the whole trajectory. Depends on 100 or 1,000 numbers. So it depends on history of what this particle was doing before. And it is symbolized with square brackets. So it is a word that Alyssa knows for sure. Okay. So action is a function of trajectory. And now we are coming to a little bit more certainty. So we are going from Prince Louis de Broglie to something more practical. So in fact, this oscillating imaginary exponent with action in its power, it's not the wave itself. It is magic stick of a wizard that converts wave function at a certain point in past into a certain point in the future. So this by multiplying, if suppose that we know wave function in the past, then we multiply it by this factor, and then we will get wave function in the future. Yes.
What does that say at the very top?
My nice calligraphy, de Broglie. I can practice it once again. De Broglie. And pardon my French, I'm not a French speaker. They have strange combinations of letters. It's written one way and pronounced differently. It's pronounced like de Broglie and it's written like de Broglie. And you can check in the Wikipedia. I make mistakes everywhere. So this was past, and this is future. So we are at the point of 11:36. So for the remaining minutes, whatever, we will keep discussing and further expanding this equation in more and more details. And right now, it looks like it is rather deterministic, but we want to bring more and more details in a way how we describe this transition from past to the future. And the equation number 3 shown at the beginning of the lecture will be a trampoline to derive Schrödinger equation at the very beginning of Monday. If we all survive, come here and continue this sequence of lectures. So the goal is to go past to the future and need more details into this imaginary exponential with action serving as angle, as argument. Nothing new. Just going from past to the future. Going from past to the future. It looks like I was not focused on repeating the same idea from different angles. This is action, and altogether, since transition from past to the future is like evolution, not in a sense of Darwin. There it's like development of all living creatures. Here is evolution like development of one little electron from a little in the past to a little in the future. But in some sense, people call it evolution operator, going from past to the future. There is a gap in my education that I cannot cover for 4 years. I was trying finding some papers, reading arguments and even lecturing them, but without understanding. I'm just giving you a little warning. In quantum theory, everything is formulated as action, integration of Lagrangian, and at some point people return back to integration of Hamiltonian. This looks awkward to me that everyone does so. And if you find details, you can make a presentation with it, earn an extra credit, so it's an interesting subject. So by some reason, people still continue to speak about trajectories, about action, but move from kinetic minus potential to kinetic plus potential. I can justify it only in one case, when potential energy is equal to 0. When plus or minus, it doesn't matter. So at least it will be okay for potential-less evolution. But we do need to look into more details of this action and this exponential. Right now, we are going rather globally. We do not have restrictions for the length of time interval between past and future. And how do we know that we do not make errors on this path? Maybe we can divide and conquer and look on the propagation in time for a very short interval of time. So dissect and look more into details of how this action is defined. If you plug in definition of this action into this exponential, what do we see? So here, I'm giving the answer that we are going to get. But before we depart in peace, we will look on more details. So basically, it is the equation number 3 from the beginning of the lecture. So we go from initial, and a function in the past, to a function in the future. And here we have exponential with our favorite imaginary unit and Planck constant. And here, in place of action, we have integration of total energy operator as function of time from initial to final. Nothing wrong. Everything goes along our philosophy and previous logical steps. But we want to look in more details what the integration means. So what is integration?
Carry on your turn.
Huh?
Carry on your turn.
Perfect. So we have a function. Right now our function is h. It is the time. It does something. And we have initial time, initial, we have final, and then we have error under part. This is good. What else? How else we can define integration? Probably correct the antiderivative, yes. And suppose that we are not humans, but assembly of smart robots. If
It's like a summation.
perfect, ideal, it is ideal. You are a perfect robot. So instead of this continuous function, one can represent it. I will draw somewhere here as set of little spikes of finite width, delta t, and then height of the function like h at t1. Here will be h of t2, right? And then we will add together height times interval. It doesn't contradict the definition of area under part. Right? So little area of this rectangular plus little area of this rectangular plus area of this rectangular. And adding together, if you reproduce the same stuff. Good? Very well. We are progressing really good. It's my nice calligraphy that probably normally the work is let me see if yeah, probably you enjoy type equations a little better. So right now I invite you to put pedal to the metal and use all of your intellectual capacity. What we are going to do is based on really strong help from model. Chop onto rectangular figures and add them together. So our time interval is set of smaller time intervals. Adding together, we will have the whole time. Our values of Hamiltonian is set of this h of time 1, h of time 2, h of 3, and then we have a main property of exponential. That exponential of summation is product of individual exponentials, right? It was written there, but I do not want to torture you this much. So there should be one line more where we have psi of the future equals to psi of the past, and in between, I have no choice than repeat and writing. So in between there is an exponential minus I h bar, and there h1 times delta t1 plus h2 times delta t2 plus so forth, right? So it is exactly what we did. But then this exponential can be from very long argument and one exponential. We can make a product of individual small exponential, right? You do permit me to do so, and you do not object. This is most important philosophical step that I was asking you for. So going from one exponential with many arguments to many exponentials with one argument. And now we are arranging them in the sequence of time progression. So the initial, or the closest to initial, will come right after here. So the next progression in time will come here. Next progression time will go here. Just we are listing times not as from left to the right, but from right to the left. And it is very important. The order matters. And as further we go into the course, we will see it again and again. So if we have very initial point of time, and we have this little exponential with very short infinitesimal progression, we can consider it as a little piece of action, a little wizard's stick that progresses, evolves, propagates our initial wave function by this delta t1 forwards to the future. Okay? So we get from the absolute past to a little bit forward to the future. So by multiplying our initial wave function by this factor from the left, we are progressing a little bit to the future. Okay. Now, look here. We have another factor. Next time interval. So we apply it to our small step into the future. And now we progress forward in time by this delta t2. And instead of the wave function at delta t1, we will have wave function at delta t1 plus delta t2. Right? If you multiply it again and again, we will step by step progress forward in the future. So we now we acted as ancient Romans, divide and conquer. We chopped our evolution operator onto small time intervals, and now we can control how we progress into the future. Not everything together, but by chopped volumes. Timeline, past to the future. Congratulations, you did most important intellectual effort for this week. I may have a couple of slides, but there will be nothing new. It will be the same idea. Main property of exponential, chopping the integral as summation, and how do we interpret what is here? How do we interpret mathematically what is going on? There is one part of the mathematical background of the Euler equation that you may know from heart, but I have forgotten to declare and remind you. What is cosine alpha squared plus sine alpha squared? Super. Now, based on Euler equation, projections are cosine and sine. And absolute, this vertical lines, absolute value, means length of a vector. So length of the exponential of this Euler function will be equal to what? 1, yes. So it doesn't surprise you, you agree. So the length of this Euler exponential is always 1. And either small infinitesimal progression into the future or overall global evolution operator, it's all just exponential with imaginary argument, right? So it doesn't change the length, the value of a function. It only changes its phase. So your wave function will not suddenly grow and bigger. Total probability will be kept the same, constant. But the change of the angle corresponds to rotations in the complex plane. So the accumulation of phase along the path will correspond to change of a phase. So it will be multiplied if you summarize whatever evolution, long or short, it will be multiplication by Euler exponential with different argument. So the factor in front will be has different phase. Okay? And the things that we will be practicing and applying our knowledge to practical things will be always returning to this feature. I hope that we will make favorites like yes. So meeting is done. Have a nice weekend. No homework, maybe for the last time. and enjoy, accumulate strengths to your other subjects. And, I look forward to see you on Monday.
For lab teaming, to the questions first.
Alyssa wants to start at 6. I want to start at 5. Let's probably we will collect more votes. I will follow the majority. But it's not yet time to start the labs. We do not have enough material behind us.
Do we have, so we don't have lab next week?
Too early. I hope you don't mind.
No, I'm okay with that. I just like to know.
Thank you.
Maybe if majority will be on your side, then I will come at 5 anyway, but we'll sit and enjoy empty room.
Yeah, it's the three of us. That
It's just
have-
gonna be next Wednesday in Fillmore, so.
Wait, what?
Is it gonna be just?
No.
No, she has class on Mondays. Every
Yeah.
Monday.
So our lab TA for
Yep.
analytical chemistry
Yeah.
has class during our scheduled lab on Monday. So
They picked the wrong TA for the lab.
so
No, she's
she
great.
wants to extend our Wednesday lab for an hour
Like all the time? I thought it was
all the
just
time.
No, she has a class on every Monday.
all the time. Oh.
Yeah.
Obviously, it is still your time, you know. Schedule.
Well, if no one will come at 5, then I can start
mean,
at
I'm
5.
sure-
Start at 5 and invest this time in preparing the lab, and keep the rest of the day empty.
But would we, the three of us, at least be okay to show up at 6?
Absolutely.
I'm just afraid that like we're gonna miss.
I'm not yet in the loop to send you, but everything will be recorded, and I will be sharing recordings on one hand. On another hand, there will be no instruction on the web. You will do just things.
And when I took before, I had a class that also went at like an hour.
Yeah,
and
you were coming hour later and didn't suffer much.
No, it was fine, but it was basically mainly because like the other people in lab that caught me up to where we were. So like I'm sure if we're late, then they start at 5. Then we can partner up and have them.
And I will administer a collection of votes. If majority will be on your side, I don't mind.
Yeah. I'm sorry about that.
That's okay.
Yeah. I mean, it's just like if we can't not go. If we don't go to analytical lab, we can
You mean like we don't have an analytical lab on Monday at all?
go.
No.